Welcome to the Crazy Hat Chemist. So today we're doing another video on atomic structure and electron configurations. Bam! So today we're talking about the electromagnetic spectrum. Okay, and with the electromagnetic spectrum, there's an equation that's essential. And here is that equation. That is C equals lambda times nu. Okay, we haven't talked about what C is equal to, but that is a lowercase c, and that is the speed or the velocity of light. And that is 3.0 times 10 to the 8 meters per second, or that number, that 299,792,458 meters per second. Okay, this is the wavelength. We've already discussed that before. That's the distance between two successive points in a wave. And this is the frequency, and that is the number of waves passing per unit of time, typically a second. Okay, so we got speed of light is equal to the wavelength times the frequency, an essential equation here. And on this slide here, you should see gamma rays, X-rays, ultraviolet light, visible light, infrared, microwaves, and radio waves. So gamma rays are high in energy, and hopefully you're familiar with that. Okay, and we want to protect ourselves from gamma rays. We get gamma rays from the sun or out in space, and we have a hard time protecting ourselves from that. Fortunately, our planet has a magnetic pole, and then those gamma rays, many of them, are protected by this, and they are shielded by our planet. Okay, then we have X-rays, and X-rays are also things out in space, but we can also experience them here on planet Earth via the dentist or something like that. That's why the dentist puts that heavy lead apron on you, okay, so to protect parts of your anatomy so that they are not exposed to those X-rays, because they could cause damage to your cells. Then there's ultraviolet light. And when I go outside, you can't see it right now because I'm inside, but my glasses here turn and color. And that means that they change in color and they become darker. Or I wear my sunglasses. When I go outside, I wear a hat to protect myself, or I put on some sunscreen to protect myself. All those things are helping to protect your skin from the damage of the ultraviolet light, which is high in energy. Then there's a small section there that is visible light. Then there is infrared light. So infrared is kind of like if you were to go to the barbecue and then not touch the barbecue, but feel the heat energy from the barbecue when the barbecue is turned on. That would be like infrared. Okay, then there's microwaves, and you've all hopefully experienced a microwave oven before. A microwave oven uses microwaves inside. Okay, then there are radio waves. Okay, radio waves is, if you listen to the radio, then you are using radio waves, like in your car or at your house. Okay, you should see that in this whole region of the electromagnetic spectrum, there's only a small section that we humans are able to see in, and that is the visible region of the spectrum. Okay, so at one far end, you have short wavelengths, high frequency, and high energy. And you see the little squiggly there at the bottom there. That means that the wavelengths is very, very short. The frequency, that means there are a lot of them in a given amount of time, and they are very high energy. So everything on the left-hand side of the electromagnetic spectrum, I'm going to protect myself against. That's why I want to protect myself against gamma rays, X-rays, ultraviolet light, or even maybe in the visible region in the violet section. On the far other end here, okay, and that's just right there is a low wavelength, high frequency, high in energy. At the far other end, you should see that these are long wavelengths, okay, and these have low frequency and low energy. I never have to protect myself against radio waves or microwaves or infrared. Okay, like I don't have to wear a special apron or something like that to protect myself against the radio waves from my favorite radio station, for example. Why? Because they're low energy, they're low frequency, and they have very long wavelengths. Okay, so then these have high wavelengths, okay, low frequency, low energy at this right-hand section of the spectrum. The visible region only accounts for a very, very small percentage of the entire electromagnetic spectrum. So it's very, very small. That's a percentage of it. Okay? And here is the visible region expanded out. One thing that I want to note here is that the intensity of light is the amount of light that you're getting, and that is the number of particles that you're receiving. That is the intensity of light. So the more particles, the more intense that light is. Okay? All right. So here's another example of the electromagnetic spectrum, except for this slide here, the picture has been flipped the other way around. So you should see on the left-hand side, you should see radio waves, and on the far right-hand side, you should see gamma rays. Okay, so if I were to start at the side on the right-hand side where the gamma rays are, those are very short wavelength, high in energy, high in frequency. And as I move to the left, I'm going to see X-rays, then ultraviolet light, and visible light up there, and then infrared, microwaves, radio waves, etc. And then there's a few little objects or things for you to correlate with there at the bottom there. That's the electromagnetic spectrum. And why are we so interested in it? Well, we're going to find out because atoms release energy, and we can see that in terms of the electromagnetic spectrum, especially in the visible region. Okay? Here's some electromagnetic humor for you to grasp a hold of. The speed of light in air is 300 million meters per second. That seems pretty fast. The speed of sound in air is 340 meters per second. Not nearly as fast. Okay, light travels faster than sound. This is why some people appear bright until they speak. Think about that. That was a great video, and here is another hat. I believe this is an octopus, and because it has 8 legs, or 8 arms rather. If I only had 8 arms, and then I could be in the octopus's garden. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I'm going to see you next time for another cool video in chemistry.